Well, good evening, everybody. So our first inverter on the new test wall is going to be the EG4 6000XP. So let's take a look. In my last video, I went over an upcoming project we have here on the property and how that project ended up morphing into a solar project, which then morphed into the need for solar charge controller, which then morphed into a need for, well, I guess not really a need, but my desire to finally build my test wall and to be able to get an inverter to try on that test wall. And so we have the EG4 6000XP, and some of you might be saying, well, this thing's been out for what, almost a year now, and you're just now getting one? Yeah. I figure we'll try it out and see what all the hype's about. And I said this in my last video, I'll say it again, no, I am not getting rid of my Victron system. This is going to be strictly a test wall for testing out different devices and components. And it would take really something that knocks my socks off for me to pull down that Victron system. And right now there's nothing that I can see. So yes, gauntlet is thrown down. So I did purchase this inverter from Current Connected with my own money. It seems to be a night and day difference compared to some of the other EG4 inverters that have been out there. Some of you might recall the problems that I had with the EG4 6500s. And I will say there were a lot of problems with the 6500s, that Voltronics line. I honestly had more problems with support from Signature Solar than I did with the actual EG4 inverter itself, because, you know, it took 9 months or so almost to get answers to some questions. But this inverter is built by luxpower, completely different from Voltronics. And so I wanted to see how different of an inverter is this compared to, you know, the 6500 that I had. And so that's why I kind of picked this one. That and the fact that it's, you know, around the price point of what I would have paid had I got another Victron 450-100 or a couple 250 70s or 60s. I can't remember exactly which ones I was looking at, but for the price point, it was very similar. And plus, it would give me the ability to test out this new all-in-one that people are upgrading to, getting rid of the 6500s for, getting rid of the 6000s for. I mean, I guess it kind of is a budget level all-in-one inverter. So with my project, I'm going to end up bringing in solar from our new coop that we're going to be rebuilding and hooking that up over here. But for the time being, I don't have that done. So I figure, well, I can at least hook up power and maybe run some load tests, see how it performs. Do we have some of the problems we had with the 6500s? I mean, I don't really have any problems with the Victron inverters to compare this to, so we're going to fall back to the 6500 problems again. Because this inverter's been out for a while, I'm just going to do a quick run through of the specs, and then I'll tell you, you know, right out of the box, some things that I liked and some things that I don't like. This is a 6,000 watt split phase high frequency inverter, 3,000 watts per leg, with 2 built-in NPPTs with a maximum VOC of 480 volts. And then the MPPT voltage range is 120 volts to 385 volts. The maximum current rating for the MPPTs is 17 amps per MPPT channel with a maximum short circuit current of 25 amps. And there's a total of 8,000 watts of PV potential that this inverter can utilize. I believe that's 4,000 watts per channel. And so in the box, obviously it comes with the inverter itself. I didn't get a weight on it. I want to say it's like 67 pounds. I'll get the right number and put it up on the screen here. Dimensions are just shy of 18 wide if you're not including the handles. If you include the handles, you're around 21 inches. And then from bottom to top, not including the mounting tabs, you are at 25 5/8 and a depth of 6 inches. Now this is not hooked up. I only have it on the wall because it was easy to get it on the wall, and it's easier to show when it's on the wall than to try to look down at it. Other things that came in the box with the inverter, it comes with this mounting template and then a bag with mounting anchors as well as some screws. I believe those are for the dongle, and then the nuts for the battery connection. You have your wireless communication dongle, your manual, and then 2 communication cables, one for battery communication and one for paralleling other inverters together. And right off the bat, I will say this manual here, the last manual that I had of EG4s was the 6500s, and this manual is night and day different compared to that other manual. It describes more, it walks you through more, it doesn't seem like it was loosely converted from a different language into English. There's a lot in here. I want to say it's over 50 pages. So I was very happy with looking at the manual. I love the fact that it came with the template. I wrote down some dimensions on this template that really give you the positioning of the center screen so that you're at eye level when you want to look at this screen. From the left and the right, you are 6 5/8 inches in. From the top, and that's the top of the bracket, down, you are 6 inches from the top, and then from the top to the bottom of where the screen is, you're going to be at 9.5 inches. And then there is a tab along the top that mounts the inverter to the wall, and that tab is 11/16 inches tall, and that's the same height on the top and on the bottom. And then there's that tab across the top and then across the bottom of the inverter as well for mounting. Now, one thing with this tab, I wish that it had slots so that you could put some screws into the wall and then hang the inverter on the wall without having to hold it up on the wall and then screw it in at the same time. Now, I will say there's a huge plus that this one has handles on both sides, so it does make it much easier to mount. A couple other things that jumped out right off the bat is the fact that this does have built-in breakers for your load, grid, and generator, as well as a 200 amp battery breaker. You have a PV disconnect built right into the side, so you don't need an external disconnect. Something else that I thought was interesting was on the side, there's actually a power switch on this side, and then on this side of the inverter, EPS is, and I don't remember exactly what it stands for, emergency power system maybe, so that it's actually outputting or inverting power to your loads. So I mean, right out of the box, there's not much that I don't like, except these tiny screws. They're another inverter with these tiny screws to get into this panel. I hate these little tiny screws because they get stripped out very, very easily. So let's take a peek inside. We take apart power stations. Why not open up the inverter and take a look and see what's inside as well? I won't pretend to know that what I'm looking at. There is a CR2032 battery on this, so I'm assuming that it's supposed to keep time and settings. We've got, and again, I don't remember what these things are actually called. Are these rectifiers on the right-hand side? Right up against the side? This is where the PV lines come in, and I'm assuming this is the MPPT boards. So the inverter board has to be back behind there. I see a giant heat sink right back there. There is the plastic coating over this circuit board, and I believe I see it on the other ones as well. Just a lot of different components inside this thing. Boy, look at that thing. Is that a choke? I don't know. I gotta stop guessing because I don't know what I'm talking about. But maybe it'll interest some of you guys just to see what's inside. So the PV lines look to be 10 gauge wire. The generator line looks to be 10 gauge wire. Actually, it all looks to be 10 gauge, but the grid line is paired up and everything's labeled nicely. I mean, it really does look like a well thought out build. So because the filter's on this side, it must draw air in from this side and then discharge out the left side of the inverter. So you'll have to remember to check your filter, change your filter, what, once a month, once every couple of months? I see a couple giant capacitors back in there. Still cool to see. From the left, we have a battery communication port and then 2 parallel ports for paralleling inverters, a set of dry contact ports, a set of generator contact ports. These 2 here are for a remote shutdown switch, and then these last 2 here are for remote shutdown power, 12 volt supply. In the middle, we've got our positive and negative battery connections. We see our 200 amp breaker is on our positive connection. Our 3 63 amp breakers, load, grid, and generator. We've got a common neutral bus bar. And if you look right down in here, we can see the neutral of both the load and the grid is paralleled together. We've got a PE, or protected earth bar, our ground bar. And then up here, we have our PV inputs for PV1 and PV2. So the grid, generator, and load connection, the wire recommendation is 8 gauge. And battery. The battery cable size recommends 1 gauge. The maximum charging current is 125 amps going into the battery, and the maximum discharge current is 140 amps. So I did get all the wiring done. It was kind of like a bad game of bloody knuckles. And let me explain. I was trying to reuse a lot of the components that I already had on hand, so I didn't have to spend more money on this test wall. The 4-inch wireway, the 4x4 wireway, just made things so hard to get some of that thick wire through. I was sliding my knuckles all along the edges, trying to pull hard. And then I was trying to cram all this wiring into undersized metal-clad conduit. So let me give you just a helpful piece of advice. Don't try to use what you have just because you have it if it's not the right stuff. I am going to have to look at upgrading the wireway, and I would say you need at least an 8x8 wireway. And I'll have to upgrade the metal clad as well to at least 1 inch. But we've got our battery cables coming around and over and behind the metal clad up into the terminals. These serrated flange nuts are inside the packaging that comes with the inverter. Over here, I did use the 4 gauge wire for my AC output. It does fit, but it is completely overkill. I got a spool of 90 feet of 4 gauge wire for like 60 some bucks after some discounts. So I had the wire, I wanted to use it. It does fit, but it's completely unnecessary. So use the recommended 8 gauge. I've got 8 gauge over here for the output. The AC input goes down through the conduit into the wireway, up to the other piece of conduit, and then over into my grid panel tied to a 40 amp breaker. And then the AC output goes down into the wireway and then up into this panel here, into this 60 amp breaker, which I already had. And then because this is a power source breaker, you have to add this little safety tab on top so that it can't come undone. I think we're ready to fire this thing up. And it's good practice when you get a new inverter, before you send any power out, to go through the settings to make sure that you have everything configured properly. Begin powering on the batteries one at a time. I don't have any server rack batteries that have pre-charged resistors. to slowly charge up the capacitors in this, because otherwise you can get a huge inrush of current and you could damage something inside your inverter. But the way that I found was easiest to do this, at least in my circumstances, there's many different ways that people can do this. The pre-charge resistors built into the batteries, the pre-charge resistor bridging across the switched positive connection, light bulbs. I found the easiest way is just to use a desktop power supply. So we need to look and see what our current battery voltage is, 52.9 volts. And then our power supply is plugged into a grid-only connection. Connect the negative to my negative bus bar. Connect the positive to my positive bus bar. We'll turn on the power supply and get it set to 52, around 52.9. That way it'll fill up the capacitors and it'll be good to go. Open the circuit breaker for the inverter. DC switch is turned off. So then I will dial up the amperage so that current can flow. And when it zeroes out, we should be good to go. Capacitor should be fully charged, and we can check that on my smart shunt because we can see the smart shunt has power. So now we can open the switch. Excuse me, now we can close the battery switch. So now I have 53 volts at my battery terminals. Since this is my first startup, or my second first startup, I don't know what the settings are of this, so I don't want to close the output breaker until I know exactly what the settings are. But we've got our power switch on the side. We'll turn that on, and we should see the screen light up. We got power. It's always a good feeling when you get power. I believe this thing thinks that it's configured for lithium ion or lithium batteries. I need to set it up because I don't have any communication and set up the same voltages from my Victron system because they're all going to the same battery bank. So we can see that there is it's not a sad face, but it's not a happy face. It's a warning, and the normal light is blinking. I'm guessing that beeping is the inverter telling me that there's something that it's not happy about. So I'm going to go to the manual and start looking at the different settings. And in the version of the manual that I got, version 1.2.0, I want to go to page 46 and start scrolling through some of these settings here. There's not that many that you can configure on the front of the inverter, so I think 29, but a lot of them might remain as the defaults. And if you hear any thumping upstairs, I'm sorry, that's my son. He just got home from school. To get into the settings, press the enter button for 3 seconds to enter settings mode. 1, 2, 3. And then you see stuff blinking up here. That's going to be the description, or the short description basically. And then down here in this box, 01, that's your setting that you're on. So setting 1 is date and time. So hit enter, we're at 2024. The 4th, we're at April. It's not the 2nd, it's April Fool's Day. And the time right now is 1909. So is this military time? It is. Sweet. Makes it easy for me. And then enter 1909 and setting 1. We'll go to setting 3, battery. So this is the one that I need to change. So we're going to hit enter on setting number 3. And we need to go from lithium ion to, oh, no battery is an option. It's not recommended in the manual, but it is an option. Lead acid. Hit enter. And my battery capacity is 560 amp hours. Beep is going to drive me up the wall. I guess I'm going to have to pick 550. Okay, and it blinked at me. So we're done with 3. So number 5 is flashing the little Wi-Fi icon. Oh, it's the buzzer. Enter. And you can see disable up here in the top right is flashing. If I hit enter, Does that? Oh yes, it turned off the beeping. Good. So now we'll go to number 7, constant voltage setting. So this is for the lead acid batteries. This is your absorption voltage. This is your bulk charge voltage. So we're going to hit enter. So mine and my other system is set to 55.2 volts. And then setting 8 is your float. And my float is 53.6. So enter 53.6. 26 is the neutral ground bond function. Because I have this set up with an AC input, I want to use the neutral ground bond from the AC input. Let's see, this setting allows the user to enable or disable the internal neutral ground bond. The inverter must be in standby to make this change. Turn the EPS output switch to off to engage standby mode. I want it to disable the neutral ground bond. By default, it is turned on. Okay, so the manual's not right because it's turned off, but the manual says the default is enable. So pay attention to that. And then that is it. So we're going to back out. So everything should be good to go. The famous last words to turn this thing on. So let's first turn on the AC input with these breakers open, just to make sure that we've got proper voltage here for the AC input. And if I check underneath, 244 volts. Let's make sure that we have 120 from each. So we've got 122 volts for one, 121.9 for the other one. Okay, so we know we're good there. From the input side, I don't know if this thing's going to try and charge from the grid or not. Does it do it on its own? I don't know. I hope not. I guess let's find out what happened. Well, let's not get too far ahead of ourselves, okay? Let's turn on the EPS switch, which turns on the inverter, and then we can check the output voltage before we close any breakers. So flip the switch on the side. 2, 1,000, 3, 1,000, 4, 1,000. All right, so 4 to 5 seconds before it actually does something. You'll hear a click, and I'm assuming that's something closing. Oh, you know what's so nice? No fans running. I know that they start kicking on when the loads come up or when you get enough PV coming in, but with nothing running on it, silence. What's the idle draw on the inverter? So switch to current, DC, zero it out, clamp. 1.26, 1.27 volts, amps, not volts, amps. The battery is 52.8 volts. 52.8 times 1.26, 66.53 watts, which is significantly better than the 6500s that I had. I think near the end they were pushing 90 some watts a piece. And this is, remember, this is a split phase. All right, let's check our voltage before we close any breakers. That would be this one here. 240 point, what is that, 5.6 volts? Sweet. And we'll check to neutral. 120.3, 120.2. Awesome. So the way I have this designed, when I close this breaker, I'm hearing a hum from my Victron system back there, and I'm trying to figure out what I did to this thing to make it start humming. That's going to be having multiple inverters going at the same time. I got to pay attention to that. Oh, the screen turns off. That's kind of nice. Oh, and one last thing I forgot. So before I mounted this thing, I had only ever seen one of these in person one time, and that was Gavin Stone's. and his green normal button was kind of like staring right at the barrel of a green laser pointer. And I remember seeing Renaissance Man had a piece of tape over his. I think Gavin put a piece of tape over his because they were just so bright. But whatever they did in whatever firmware version this is running, I actually don't know. It is not that bright anymore. I mean, I can stare right at it and it's, yes, I still see a green dot, but it's no brighter than the green indicator lights on my Victron inverters. So that's good to know that they fixed that. Where was I? So much going on. So we've got our double 60 turned on as our output from our inverter. So if I turn on the double 30, there we go, 240 volts, 120 on that leg, 120 on that leg, good. We'll turn these on. Well, this is L1, 120 volts, and we got nothing right now. And turn on L2, 120 volts. And I do have to get covers for these, yes, I know. This I got the wrong size of, and that I got the wrong type of. It never fails. Let's try a load. I made a mess, so I'll just plug the vacuum in, and I'll clean up some of my mess. And we'll turn that on in 3, 2, 1, go! Awesome! Now what does the inverter show us? I keep thinking it's a touch screen. Wouldn't that be nice? 1.19 kilowatts output, 120 volts. So leg 2, nothing. Leg 1, 119 volts. And we can see right here, 52.4 volts with 1.23 kilowatts coming out of the battery. I don't know what this is up here. That's something A40. I don't know. Maybe that's the firmware version. 39% load on leg. There's a tiny little number that shows up on the bottom right. 0% on leg 2, 39% on leg 1. Oh, apparently there were fans running too. They're winding it down. Okay, so final initial thoughts on the EG4 6000XP. We got it mounted, we got it wired up. We got power, output power here. We've got input power to the inverter. We just don't have any PV yet. I mean, for not having put it through its paces, so far I like it. It's not bad. I mean, I love the fact that, I mean, the breakers alone save you money because, I mean, you got four sets of breakers plus the disconnect. That saves you a lot in extra components that you would normally need. The wiring space, I mean, you've got you got 4 inches. I mean, it's not a lot, but it's not super tight. So 4 inches of workable space. The display, I think the display could be better. I don't like the tiny screws, but I've never liked the tiny screws. This would have been nice to have the 18K PV's hinged door. That would have been sweet. I know it doesn't have to be waterproof, but still having the latches and the hinged door, even with the locks on them, that would have been nice. It's got low idle. That's good. I don't remember what I said. Was it 64 watts maybe? That sounds right. It's split phase in one inverter. That's nice. I liked the handles when I had to mount the thing on the wall. I like the mounting template. I do wish that the tops, the mounting points were slotted so that you could, hang it, put your screws in the wall and then hang it off of those screws while you're setting the bottom. You have to hold this up against the wall or have somebody else hold it up against the wall in order to get it screwed in and mounted. I mean, it's not that bad. It's not super heavy. So far, I mean, it seems nice. We'll have to go through and configure the app go through and look at all the different settings in the app. We'll have to do some load testing as well. See what line imbalance we can mess with. And I know that I won't be able to run my entire house off of this. It's 6,000 watts. I mean, my hot water heater in my well might throw it over the edge. Or if anything else, if the microwave kicks on when the hot water heater in the well is on, that'll overload it. But what does it do when it overloads? I don't know. Does it just die? Does it fall over the grid? I don't know. I have read the book, but I actually read it a while ago. So I don't remember what it does. Guess we're going to find out together. So lots to do, lots to test. I can't guarantee that all the next videos are going to be related to this because I got a lot of other things still with the Victron stuff to do. So it's going to be kind of back and forth a little bit, I think. But it should be fun. And then, yeah, we've got the whole project outside to do. So lots to do. Never ends. But that's what makes it fun. There's so much to do. Stuff's constantly changing. I got lots of stuff on the burners, we'll say. But with that, I'm gonna let y'all go. Y'all stay safe, stay warm, and we'll catch up with you later.